Let's do some hands-on of salting. First, what will I do? I'll execute this code and just show you the skewness that we had seen in the previous example or in the previous hands-on. And then we'll remove the skewness using salting process. The name of the application is data skewness, and I think I have group by and join. I have put both of them in the action. So the total execution time was 30 seconds, and this is the application data skewness. I'll have to go to stages directly, and these are the same stages that we had seen earlier also, but this time around I had actually performed two actions. Anyway, so this is the stage that I think had the problem with a duration of 12 seconds. And if I select, and this was the problem, it took 12 seconds. And if I scroll down and refresh, the median is 1 millisecond and the maximum is 12 seconds. So there's a difference of 12,000 times, and we want to fix this. This is the skewness problem that I was talking about, and we want to fix this using salting. So let's go ahead and do the coding for salting. And this is a boilerplate code. The name of the application is Spark Salting. Let me put underscore test because we'll be doing a lot of testing. I have not done the coding earlier. I'm doing it for the first time for this particular dataset at least. And I have selected these columns, and this is the flight dataset and the passenger dataset. At the same time, I'm removing the duplicate rows with passenger country and passenger name. I mean, where the duplicate values are as per passenger country and passenger name. And you already know that df underscore flight, this data frame is skewed based on the passenger country. So what we have to do is that we have to first find out the skewness. You already know that, but still let's find out the skewness. At least we know that it is based on passenger country, and then do a count. Why am I doing this? Because we want to find out the number of partitions. Okay, so France has 1 million rows, Spain has 10,000 rows, and USA has 15 million rows. So let's do one thing. Let's create a partition of 30 maybe. Each partition will have 500,000 rows. So that would be the partition number. Let me just write it down. So each partition will have 500,000 rows, and we are considering a total number of partitions of 30. Okay. Now what I have to do is that first we'll have to create a dummy column so that I can salt df underscore flight, which is actually the skewed data frame. So df underscore flight underscore salted maybe equal to df flight, and then we'll use with column. Now I think we'll have to do a lot of coding here, and not coding actually, a lot of logic that we'll have to apply. We'll have to think what functions we'll have to use. Anyway, let's name the column as new country code flight. Now after this, what we have to do is that whenever the country code is USA, we'll have to make sure that the random country code is between 1 to 30. And also at the same time, we'll add the country code followed by hash. So we'll have to use the when function for sure, and I'll have to import it. So when df flight dot passenger country is equal to USA, then we'll have to get a random number between 1 to 30. And Spark has a function called rand, which gives a random value between 0 and 1. It does not give you random value like Python. So let's import that rand function. What will I do is that I'll use this rand function, and it would be anywhere from 0 to 1, meaning that it would be in decimal. So first let's try to execute this and see the output. As I told you that it's always better to see the output all the time. I'm not sure it can give error also, or syntax error also, right? I'm not using otherwise. Okay, it is not giving error. So nice. So this is the random value. As you can see, it is 0.39, 0.49, but it does not make sense, and it will not work for us because we want a random value between 1 to 30. So what we can do is that we can multiply it by 30. If we multiply it by 30, even then it will not be proper because we'll see in the output that it would be a decimal number rather than integer. But to fix this, what we can do is that we can cast it as integer. So let's cast it as integer, and we'll have to import the cast function also. Okay, so this is done, and let's look at the output now. Okay, so now it is working. So the individual values are in integers, but we'll have to concatenate the country code also, like it, which is USA. So it should be USA hash this number, and for that we'll have to use concat. Let me put the when a little bit so that I can get space. And what will I do now is that I'll have to concatenate it. So let's use concat. I'll be using the passenger country and then the literature hash. Okay, so it should be dfflight.passenger country. Okay, now I'll have to, of course, import concat and lit. Okay, let's look at the output again. I hope there's no error. There might be, I'm not sure. It worked actually. All right, so it worked. So we are getting the proper output. Okay, so this is the first when, right? This is where the when ends. And what will I do is that I'll do the same for France also. When passenger country equal to France, same thing. Otherwise, it should be just dfflight.passenger country, because we do not want to do anything with Spain. The number of records for Spain are anyway less. Okay, so now let's see at least 500 records whether the salting has been done properly or not. And here you see I have used the when function, the rand function, the concat function, and lit function. I've discussed all the functions except for rand. Rand is something that actually creates a random value between 0 and 1 in decimal places. So that's why you had to do the multiplication with the number of partitions. Every country is USA. Let's do a filter of France maybe. I just want to see whether the salting has been done properly or not. Okay, France is also working. Let's look at Spain. There should not be any number in Spain because we are not adding any salt value to Spain. By salt value, I mean a random value, and Spain should be plain. So the DF flight data frame has been salted. We have added a column. Name of the column is new country code flight. For France and USA, the salting was done properly, because those are the two skewed columns. We could have done it for Spain also, but I did not do it. We could have mentioned otherwise concat some value literature followed by cast. Same thing we could have mentioned for Spain also, but I did not do so. Okay, so now what I'll have to do is that I'll have to create a salted value of the passenger. Now this is a little difficult because what I have to do is that I'll have to first make sure that each row is repeated 10 times. After the repetition is done, then only I can solve the data frame. So let's create passenger 1. What I have to do is that I'll have to make sure each column is repeated 10 times. Not 10 times, sorry, 30 times, because that is the number of partitions. 10 times was in the example of the PPT. Anyway, there is an option, and I have not shown you that function. As I said, the list of functions are way higher. Obviously, you can look at the documentation about what functions are there. It's not possible to remember each and every function. So whenever you think that you have to use it, please go ahead and use it. Do a Google and get the function name. Now in this case, what I have to do is that I'll have to convert one row into 30 rows. That is my purpose. How do I do that? I have not told you about the explode function, but what explode function does, if we have an array, let's say, of 30 elements, explode function would create 30 rows with one element in each row. So let's say the array is 1 to 30 for a single row, and if we use the explode function, then explode would convert that one row into 30 rows, each row having only one unique element from the array. So for that, of course, we need to have an array column. Let's name it as array column itself. And there's a function called sequence. And the moment I added here, it got automatically imported. So I'll add a sequence, and the starting should be 1 and the ending should be 30. Okay, so of course, let's do a show. I hope it works. I hope the syntax is correct. And it did work. There should be 30 unique columns here. If you use the truncate flag here, of course, I'll be able to see all the 30 arrays. So this worked. And now what will I do? I'll use the explode function and df passenger 1 with column, let's say country code maybe, and I will explode, and inside of explode we'll have to mention the column that you want to use explode for, and it is giving error, so we'll have to import it from the function. Okay, this should be enough, I guess. Let's do a show. All right. Okay, so as you can see, for the same value, right? So this name Alia Bapre, it has, I don't know how many columns, but anyway, each unique element has been exploded in the country code. Correct? So that's what we wanted. Of course, this is not the correct value. You'll have to make sure that we concatenate this explode output with the passenger country. And for that, we'll have to use the concat function. And here, I'll have to use 3 rows. One is let followed by hash. At the beginning, I'll have to use the passenger country. Okay, so hopefully it works, and let's try it out again. Okay, it is giving error, unsupported generator nested in expressions. The generator is not supported. Passenger country explode. Okay, so it looks like I cannot do it here. The explode function and the concat function cannot be used together. That's what it says. The generator is not supported, nested in expressions. The generator is actually the explode, and we cannot put it in concat function. So I'll have to remove it. That's okay. So I think we'll have to use another data frame 3, and here I'll drop the array column. I don't think the array column is needed anymore. Okay, so now here I'll use df passenger 2 and then with column, and I think now I can put this column name new country code underscore passenger. Here I'll be using the concat function, and in the concat function I'll be using df passenger 2 dot passenger country, then the constant hash, and then df passenger 2 dot country code, because the country code has that 1 to 330 value, right? So this should work. Let's look at the output. Okay, so the output is correct. We have this new country code passenger, and I think we can drop the column country code, and nothing else is needed. Okay, so this should be actually passenger salted because we have done the salting. Now both the data frames are salted, meaning we have added columns with random values in both the data frames. And now if I use join transformation and the join column should be the salted columns, then there should not be any problem. Let's see. It should be df underscore joined and equal to df flight salted dot join df passenger salted, and we'll have to do some joining here. It should be new country code passenger and new country code flight. These are the salted keys, remember that. And it should be an inner join. And after this, of course, we'll have to drop a lot of columns, but let's do a show. Okay, unresolved using join. Sorry, I did not follow the best practice. It should be df passenger dot salted equal to df flight dot salted, and I think I'll have to mention the passenger name also, because last time also we were not doing the joining based on only one column, right? Because it will go for Cartesian product, which you do not want. And I'll put passenger name here in both the cases. Let's see whether it works or not. Okay, it did work, it seems. And we have a lot of unnecessary columns. We'll drop all these columns and then we'll run it one final time. I think I have dropped all the necessary columns. Let's run it one final time, and the name would be underscore final. The output looks correct. Let's compare the latest run with the data skewness. Of course, if I refresh it, there would be a lot of tests. And as you can see, there are so many tests. Let's look at the first run with the skewed data. And it took 12 seconds. And the difference between median and maximum was 12,000 times. For the final application, it took 0.6 seconds. There's 16 seconds also. Let's look at all the stages one by one. For the first stage, there is no data skewness as such. For second stage also, I don't think there would be any data skewness, 0.4, 0.42, which is okay. Only 5 times. For number 3, there might be some chance, but let's look at it. Okay, there is no data skewness. Median is 3 and 75th percentile and max is 4. No skewness at all. And let's look at number 4, 0.6, 0.6, 0.6. So we were able to completely eradicate the data skewness problem. But let's look at the overall time. How much time did it take? It took around 23 seconds. The total duration was 25 seconds actually. And with data skewness, it was 30 seconds. Now it is only with small amount of data, the difference becomes wider if the number of records are higher or the file size is higher. But at the same time, there's a lot of complexity. The first complexity is that the non-skewed data frame actually got bigger, 30 times at least. And then you have seen the code also, the logic of the code for salting was pretty daunting. It's not straightforward. We had to do a lot of engineering in the code to do the salting process. Adaptive query execution tried to solve it, but salting is still relevant in today's Spark versions also. You might have to use salting in some of the cases.